Hey there kids, welcome to another 5th grade math video for Eureka Math. This is Module 2, Lesson 3, and it's homework. So as I always recommend, please go watch the problem set video before you try the homework. And before you watch the homework video, do your homework. Do it first and use this as a check-in. The homework is designed to have you practice and try your best before you just double check in with the homework. Always try first, then check in with the video. Okay, so today what we are doing is we're taking this algebraic terminology and we're making pictures. So we're going to draw a model, then we're going to write the numerical expressions. So let's get started. You have to know what sum is. You have to know what product is. You have to know what difference means. So there's going to be some terminology that if you don't know what it is, please try to know it now, learn it now, memorize it, because it's just going to keep coming this year. So our first expression is the sum of 21 and 4 doubled. Now when we are writing the expressions, we're not solving today, we're just writing. So what it is you're doing, you're proving that you could set up this problem and solve it. They don't care for you to solve it in some of these, but they just want you to set it up. So when they say sum, we need to add. What are we going to add? 21 and 4. When we get the sum of 21 and 4, we're going to double that. So we've got several things to do here, and we have to draw a picture of what that looks like. So let's start with the picture. If I have 21 and 4, like that, in a sum, I could call this a unit, okay? So it's the sum of 21 and 4 doubled, okay? So the sum of 21 and 4 doubled. Now, how is that going to look with a numerical expression? When you double something, you're 2 times the number. When you have another operation in the same expression or number sentence, if you have an answer, you have to collect the information with parentheses. So we're going to have 21 and 4 in parentheses. Today's lesson, lots of parentheses, very important. What if I wanted to do the sum of 21 and 4 doubled? Yes, you can, because according to the commutative property, if I have the parentheses around these, then I can move this, which would be a factor. 21 plus 4 would be your 25. And so if I keep this together, then I can shift the location. Okay, so that's your picture. This is your expression. And that's what we're doing today. So let's jump along and go to B. 5 times the sum of 7 and 23. So now we have 5 times, but we need the sum of 7 and 23. Okay, now if you have writing, numbers, whatever, and it's really big and you're like, I can't fit that in the box. Do I have to put it in the box? You don't. But you do have to identify what is in the box, and that you would have 5 of those boxes. 1, 2, 3, 4, 5 boxes, each representing the sum of 7 and 23, 5 times. Then your numerical expression, 5 times, parenthesis, the sum of 7 and 23. Can you switch it around? Yes, you can. This one starts out with 5 times, so the logical way to write it would be 5 times the sum. This one starts out with the sum of 21 and 4 right here. The logical way to write it would be like this. But can you switch it around? Yes, you can, as long as you keep the parenthetical expression together. Another one. 2 times the difference. Okay, 2 times, this is going to be a 2 times, the difference, which means subtraction. Subtraction between what? This and this. So now I have to have in parentheses my 49, so 2 times the difference between 49.5 and 37.5. First, in PEMDAS, you will get the answer to the subtraction problem, because in PEMDAS, the P stands for parentheses. And I think I have another video on here. I have so many, I can't even keep track. But I have a video about PEMDAS, so search it up, setness, PEMDAS, order of operations, and then hopefully you can get that one. It's like a special video. I don't think I have anything else on it, not a lesson, but it really will prepare you for this. Anyway, so we have 2 times the difference between the 49.5 and 37.5. And so if I have this as my 37.5, if I have this as my expression in parentheses, it's going to be 2 times that. Okay? Sorry, that's so crunchy there, crunched in, but 49.5 minus 37.5, and then that doubled, so 2 times the difference. Next one, we have sum. We're back to adding. The sum of what? 3 15s and 4 2s. So what does that look like? Well, when I have different numbers, like I've got 15s and 2s, you can have, say, 3 boxes here, and that shows your 3 15s, and then you can have 4 2s, and your model can be put together like this, like it's the sum of those items. So there are different ways to show it, and a lot of people will say, oh, well, my model looks different. And as long as it's mathematically accurate, like you're showing that this is being repeated and you're putting these together, then you should be in good shape. So I'm just trying to show you different ways to put things on paper so you can see your thinking. Okay, so if I have 3 15s, that's actually 15 repeated 3 times. Okay, and so then I'm going to have a sum of this and what? 4 2s. So it's 2 4 times. What if you had 4 times 2? Would it be fine? Yeah, that's fine too, because the commutative property, switch the order. Okay, so this would be your expression for this picture. If you worked it out, you would have your answer, and then they would say solve it. But we don't have to do that right now. Next one, the difference between, and again, difference is subtraction. Subtraction between 937s and 837s. 937s and 837s. Okay, so what does the difference look like? So if I had, let's say, a tape diagram, and I have 9. Ooh, I'm going to try to squeeze this in. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's 37 that's being repeated. 37, 37. You can fill it in. And the difference between them and 8 37s, 1, 2, 3, 4, 5, 6, 7, 8. Make sure you've got the right amount. 37, ... all the way over to here. When they talk about the difference between, what they're talking about is this out here. The difference between them is this space. Okay? Because if one of them is this far and one of them is this far, then that's the difference between. That's what difference is. Okay? So next one, triple the sum. Triple the sum 3 times the sum of what? Okay, we have to add those. So if I have a 45 and 55, and again, you don't have to fit it all in the box, you just have to triple it. And you have to show that you have the 45 adding to the 55. So then your numerical expression, 3 times the 45 plus the 55. So once you get the sum, then you can multiply it by 3. Okay, what if you switch it around? Will it work? Yes. Sorry, moving the paper, and we'll go on to the next one. Next page. This is a 3-pager, by the way. Don't think you'll be done after 2 pages. Sorry to disappoint. Write the numerical expression in words, which is what we had over on the previous page. This is a numerical expression in words. But here they've given you the actual expression. Okay, so here's the expression. Now you have to say it. So it's testing to see if you can read it properly. And then we're going to solve. Okay, so that's kind of fun. So what do we have here? Well, we've got 10 times. 10 times what? Use the word sum and talk about joining. So we're just going to say, 2.5 and 13.5, but actually we're not going to say, we're going to write the numbers. So bear with me and let's write it. So it's 10 times. You can use the 10 times the sum, because remember you got to use that word, of what? And then that's when you can use the numbers 2.5, and don't put plus because you already said sum, so that means plus 13.5. Okay, so 10 times the sum of 2.5 and 13.5. If you want to read it correctly, 2 5/10 and 13 5/10. Okay, that'll help you when we get into other word forms. Now the value of the expression, remember, you have to solve things in a certain order. So when you have your 13.5 and your 2.5, you're going to line up the decimals when you add and subtract. 5 plus 5, 10, carry it over, decimal down, 3, 4, 5, 6, carry, nothing to carry, bring down the 1. So we have 16. That's only the sum of the 2.5 and the 3.5, 13.5. Now we have to take that and multiply it by 10. That's okay. You should know how to multiply by 10. Go back to, I think it's lesson 3 in module 1. 16.0 times 10. Shift these left once or the decimal right once, and the value of the expression is 160. So they'll give you something that's kind of easy once you figure it out. Okay, next one. You would not say 98 minus 78. You just don't. When you see a subtraction sign, you're going to talk about the difference. Okay, so you want to say 11 times the difference. The difference. Use the math words. Don't say minus. 11 times the difference between 98 and 78. Okay, so you want to use the terminology like this because that's more correct. And then we have to do the steps in order. No multiplying by 11 yet. First, do the subtraction. According to PEMDAS, everything in parentheses has to happen first. What's the difference between 98 and 78? Well, they gave you a nice easy problem. That's going to be 20. So it's going to be 20 times 11. Like I said, easy problems once you figure it out. 11 times 2 is 22, and then with the extra 0, it's going to be 220. Next one, sum and times 26. So we can do 26 times the sum of, remember how to say it, 71 and 29. First, solve this. If you move this right over here so you don't have to rewrite it, you can add them up and keep your columns nice and neat. If your writing is too big, just put it on the side or a piece of scratch paper. 9 and 1 is 10. Carry that over. 7, 8, 9, 10. You have 100. That's the final answer to this times 26. When you have 26 times 100, you're going to end up with 2600. Because you can put those 2 zeros right in the end. It's a whole number. That's why we can do it. Okay, sum of. Start with the sum of. Now, what are we taking the sum of? You could say 52s or 2 50s, and 2 15s or 15 2s. Let's call it 2. So the sum of 2 50s and 2 15s. Now when you solve that, again, first multiplying 50 times 2, what's in parentheses, left to right. 50 times 2 is 100. We're going to add that to 15 times 2, which is 30. 100 plus 30, 130. It's not so bad, right? Maybe? I don't know. These are usually some tough lessons. Number 3, compare the two expressions using greater than, less than, or equal to. Here, but this is not what's important. It's everything else. So some kids will be like, oh, greater than, less than, equal to, whatever, I'm done. No. In the space beneath each pair of expressions, explain how you can compare without calculating. Draw a model if it helps you. Okay, so I want you to look, without looking at the next one, look at the expressions we're comparing. Left side, right side. I have a 93, I have multiplication sign, and I have a 40 plus 2. Over here, I have a 40 plus 2, which is the same on the left and the right, times 39. So what you want to do is you want to eliminate the things that are the same, because those are equal. If everything on both sides is equal, then you'll put equals. But anything that is the same, just take it out, because anything that is left, you can compare and see that it is or is not equal. This one is 93 compared to 39. 93 is greater. I did not calculate anything. I just looked. I'm looking. So basically, your explanation is 40 plus 2 is the same on both sides. Eliminate that. So you only have to compare what's left, which is 93 to 39. Okay, so that's your strategy. This is going to happen a bunch of times, and it's going to be on your tests. So please know that's how you do it. Here's another one. 61 times 25. So we have a 61, we have multiplying, and we have 25. Here's an expression, so you have to kind of understand what's happening. 60 25s. This is 61 25s. This is 60 25s. Minus 125. Okay? So I have 61. And on this side, I have 60 minus 1. They're all talking about 25s. 25s, 25s, 25s. This one is 61. This is 60 minus 1. Well, if 60 minus 1 is 59 25s, then I have one fewer than that, which was one fewer than that. So this side is greater because we have 61, and this only has 59. I didn't calculate. I'm only showing how to use the words and the numbers to compare. Okay, so 61 is greater than 60 and also greater than 59 25s. Okay, so you're looking to figure out, what am I comparing? Okay, pretty sure you're going to have this on assessments as well. Turn the page to the last problem. Okay, now this one, it'll focus. Just give it a second. See, it's just so compliant. Thank you, little iPad. Okay, Larry claims that 14 plus 12, altogether solved, times 8 plus 12, altogether solved, and 14 times 12 plus 8 times 12. Notice all the different locations of the operations. He says that they are equivalent because they have the same digits and the same operations. This one has a plus and a times and a plus, and this one has a times and a plus and a times. Do they have the same operations? Is Larry correct? Explain your thinking. So basically, what we're doing is we're looking at what are the numbers that we're creating. We've got a sum, and then we've got a product being added to another product. So the size of our numbers are going to change, and then what we're doing with them is going to change. So let me show you what's happening here. So if I have our 14 plus 12, I end up with 26. And then if I have my 8 plus 12, I have 20. And I'm going to multiply those two. So I'm multiplying some bigger numbers. Now just take a little break. And I have 14 times 12 over here. Okay. Now you haven't maybe remembered how to do double-digit multiplication, so you could use an area model, but I'm just going to use the standard algorithm so we can talk about what Larry is thinking. So 2 times 4 is 8, 2 times 1 is 2, and then below that we're done with the ones place, so hold it with the 0, and then 1 times 4 and 1 times 1. Add those up, and you get 168. That's for the 14 times 12. But to that, we have to add the 12 times 8. And you might say, oh, well, we're going to add, and this is going to be a pretty big number too. But 8 times 2, 16. 8 times 1 is 8 plus 1 is 9. We have 96. So we're adding some pretty big numbers, but here we're multiplying some pretty big numbers. When you multiply, you tend to get some good size numbers. So let's take our 26 times 20 or 26 times 2 and add the 0 on the end. If you want to do the standard algorithm, 12, 4, 5, don't forget the 0. If you want to do, that's basically this one, 2 times 6, 12, 2 times 2 is 4 plus 1 is 5, 0 comes down. Okay, so it's 520. Compare that to the 168 plus 96, if I move it over here, so I have lots of room, 14, there'd make a 10, 16, and we have 264. So now I'm comparing 520 to 264. And so you have quite a difference. If you're creating some decent sized numbers, but you multiply them, you may get a really big answer. If you have some decent sized numbers and then you add them, you're not going to be increasing the size of your product at the same rate. So the different groupings, that can be your explanation, create factors or add-ins of different sizes. Okay, and so multiplying can create, and it really depends on the size of your factors, can create large products. Okay, so you can't say a blanket statement all the time because you might have larger add-ins, but in general, multiplying is going to create larger products as opposed to adding. Now, which expression is greater? We've just solved it, so we know that we have 520 versus 264. So we know that that one's greater, but exactly how much? Do subtraction. Find the difference to see exactly how much. 0 minus 4. Can't do it. Take 1, give 10. 10 minus 4, you can do it. 6. 1 minus 6, can't do it. Take 1, give 10. 11 minus 6, 5. And 4 minus 2 you can do. And you end up with 256 as the difference, and that's how much greater. Woo! Kind of a tough one, but I hope this was helpful, and I hope you click subscribe and come back on a future video. Bye for now.